Hi, everyone. I'm Cheryl Lau from the University of Waterloo, and I'm very happy to be here today to present our paper, which is called Attribute Spaces, Supporting Design Space Exploration in Virtual Reality. This work was developed with Haijun Xia, Daniel Wigder, and Fanny Chevalier. In recent years, we've seen an explosion in consumer VR, and with that comes the need for high-quality tools that allow designers to create VR content in VR. One of the problems with current workflows is that there's a disconnect between the medium of creation and the medium of consumption. The current typical workflow for a designer who wants to create a VR experience is that they create almost all of the experience in various sophisticated desktop software and then preview the results in a VR headset. There are some tools that let you design in VR, but these tools are often limited or ports of existing desktop interfaces to VR. Much like designing for any other medium, VR content creators work by iteratively comparing design alternatives and curating design options to create the best potential experience for viewers. To make informed design decisions, a designer must be able to accurately preview how an experience will appear to their end user, but authoring in VR is still a largely segmented and cumbersome workflow. Figuring out which design parameters are possible, iterating over design variations, comparing different options, and reviewing previous design decisions are all steps in the design space exploration process. Parametric design is an existing design paradigm that uses these ideas of designs as collections of attribute settings. There's quite a lot of work on design space exploration, such as the sequential gallery by Koyama et al. And the design space exploration tasks described by Shireen et al. These served as guideposts as we begin determining the requirements for a VR design space exploration tool. Our main inspiration for non-destructive and concurrent editing in VR came from Xia et al.'s spacetime tool for collaboration in VR. In their system, parallel versions of objects could exist in a scene and be edited simultaneously by different designers. We were also motivated by the reification of design attributes in histemages by Chevalier et al., where the colors of each pixel in an image was plotted in a color histogram that could be directly manipulated. The M-axis system by Corday et al. Is a great example of how the separation of degrees of freedom afforded by VR interfaces can be used to make visualizations more compelling and interactive. The modular nature of the visualizations is another aspect we try to integrate into our tool. Our design goals for this VR tool were inspired by the work on design tools by Resnick et al. And are summarized here. So number one is supporting the reification of the design space attributes and variations. Number two, enabling rapid non-destructive exploration of the design space. Number three, supporting creativity through design suggestions. And number four, enabling flexibility in the creation of custom design tools. To address all those design needs in VR, we created attribute spaces. Attribute spaces are 3D visualizations of design space attributes that designers can interact with in VR in order to edit the objects in their scenes. Each attribute space takes the form of a set of orthogonal axes where each axis represents an attribute. The designer can add proxies to the attribute space, which are basically links to objects in the scene so that you can edit their attributes. The location of the proxy in the attribute space encodes the relative value of the attributes for that object in the scene. When you move the slider on any of the axes, that attribute is augmented by the amount that you move the slider for all objects that the proxies represent. If we think of the design space as a multivariate dataset, attribute spaces offer a visualization of a subset of those variables. We can visualize 1 to 3 attributes in a design space and see the relationships between the attributes through the locations of the proxies. Designers can construct their own attribute spaces by assembling sets of attributes into attribute space volumes. The proxies in the design space reflect the changes that are being applied to the scene objects by that attribute space and serve as a world in miniature view of them. All the changes applied by the attribute space are reflected in real time in the scene if the attribute space is active. These features support our first design goal of reifying the design space attributes. Attribute spaces can be adapted to support the control of any attribute that can be parameterized into one dimension. Moving the controls along an axis, either by grabbing the sliders on each axis or moving the control cursor, adjusts the attribute represented by the axis for all of the proxies in the attribute space. Since multiple attribute spaces can coexist, each one acts as an independent area for concurrent experimentation. To rapidly compare design variations with the original, designers can simply release a grab attribute space to deactivate it. The operations applied by attribute spaces are non-destructive until the user explicitly applies an operation permanently, which supports our design goal of non-destructive operations. Seeing changes to attributes in a VR scene in real time can provide a designer with an accurate preview of what the end users of their products will see and help facilitate better design decisions. When working on a scene, a designer should be able to group the attributes that are commonly edited together to help conceptualize the different operations that make up common actions in the scene. With attribute spaces, designers can modularize design tasks into their attribute components and mix and match. Now, one limitation that you might have thought of is that attribute spaces are limited to 3 axes each. To enable more active augmentation simultaneously, we implemented a grouping feature where attribute spaces can be stacked on top of each other and linked. If linked attribute spaces contain proxies representing the same objects and have the same attributes, the value of the attribute space that's higher up in the stack would take precedence. By allowing designers to take control of how attributes are grouped, we support the flexibility of the tool. Designers have the ability to save attribute spaces when they want to bookmark an interesting configuration to view or edit later. By saving interesting designs, they can continue working on their current scene and then activate attribute spaces to bring up past versions of their work. In a collaborative setting, this feature is valuable for discussing alternative designs with other members of the creative team, possibly asynchronously, as it allows for the operations to be applied non-destructively to scene objects. These saved attribute spaces can be reused as presets to apply the same set of operations onto new objects in the scene. Attribute spaces support the communication of design constraints through the creation of constraint objects. Constraints are individual points in space that can be connected to create areas and volumes. The randomization feature will avoid picking values within the constraints. However, the user can still choose to place proxies within the constraint area if they want to. Constraint objects offer a visual annotation of the areas of the design space that should be avoided and are saved as part of the attribute space. If a designer wants to remix the attributes between 2 different attribute spaces, they can interpolate between them to get an attribute space with a mixture of the axes. As seen in the video, the designer just needs to tap 2 attribute spaces together, pull them apart, and then pick one of the interpolation points from the generated list. The resulting attribute space could offer a new perspective on correlations between attributes because they're plotted on the same set of axes. As we touched on earlier, attribute spaces support the randomization of configurations and axes. A designer can add a proxy to an attribute space and then randomly generate new axes that make sense for the set of objects represented by the proxies. Once the axes are set, the configurations of the axes can also be randomly reset. This supports our goal of providing design suggestions. To evaluate our tool, we ran a user study with 8 3D design experts who were asked to go through a 1-hour session with a mix of guided and unguided explorations. All of our experts had VR experience and previous experience with 3D modeling on desktop applications. Half of the participants even had experience creating VR content in VR. The participants went through a guided exploration of all the attribute space features, followed by about 20 minutes of unguided exploration, where they were told to make a tropical VR scene seem happier, however they interpreted that. The idea was that we would try to see which features they decided to use when they were not prompted to go through a specific set of steps. Because our participants were 3D modelers with existing workflows, we received some interesting feedback on how it compared to their expectations of a 3D design interface. Participant 1 said, quote, "It adds a play element, but not sure of a productivity element," which is fair because the goal of the project is to enable exploration more than faster conversions to a certain design. When talking about the parallel workflows that attribute spaces enabled, participant 2 said, "I like that they could be saved and previewed. It was like having a preset style that you could apply and they'd be visually there." When discussing the constraint objects as annotations, participant 4 commented on how it was quick to pick up on someone else's work and know that they didn't find that range of options desirable, which is useful. On the overall design of the tool compared to other VR interfaces that participant 8 had used, they said, "I really like the idea of manipulating attributes spatially. It felt much more satisfying to have something work when you're moving your body to do it." For the random configuration suggestions, participant 7 said that the random configuration tool could work as a creative mechanism to give some inspirations. So some of the participants noted that the randomization tool, while useful for inspiring new explorations, sometimes gave them results that were very far outside of the range of what they expected. In future work, we'd like to enable more user control over the randomized suggestions so that the user can guide the randomization as they progress. Another limitation of this work is that we only support independent attributes. Obviously, not every design attribute is independent, so future work might focus on creating a grammar for expressing when attributes are interconnected. The last interesting avenue for exploration would be attribute spaces for animation. Each keyframe of an animation could be represented by a set of attribute space augmentations and then strung together to create an animation. To recap, attribute spaces are tools that enable in-situ editing of VR content through flexible visualizations of design attributes. They're a new way for designers to explore the design space in a VR setting and to see their edits reflected in the scene in real time. The design suggestions can help boost creativity, and the modular nature of attribute spaces allow flexible creation of design tools. Our contributions in this paper are threefold. We articulated the set of design goals for a systematic exploration of design spaces in context. We presented a proof of concept prototype that simulates how attribute spaces could be used in a designer's workflow. And we also presented the results of an expert evaluation of the prototype by designers of 3D environments. Thank you all for attending our talk today. Please refer to our paper or contact us for more details on the project.